Okay, so I know one of our students asked about the hardware. Yeah, so now we're going to talk about the hardware choices, and you show us to choose a reasonable, more economical GPU.
Yes.
Okay, right?
Did you ever buy yourself a computer?
A laptop.
A laptop. Okay,
A
great.
laptop. 10 years ago.
10 years ago.
Can you believe it?
Oh yeah.
Yeah.
It's hard to believe. Can it run now?
Yes, really. I can show you after class.
Okay. I think this topic, hardware choices, many of you may be interested in it because the data science or AI engineers who dedicated to this field they all want to build their own hardware computer facilities. And we have do a lot of experiments. We have make many errors, and we have learned a lot from this. First, I will share one paper result from in the 2019. This paper do the benchmark, and it used the RTX, IBM P9, AWS P3, and DGX2 to benchmark with the ImageNet image, which is 224 by 224 pixels. First, we look at the ResNet 152. ResNet 152 is relatively a large model. It has a lot of parameters. And in this large model, we can find the diagram shows the performance is proportional to the number of GPU. We say it's linear. It has linear correlation. But in another model, ResNet 18, it shows not exactly proportional to the number of GPU. Why? We think the problem is ResNet 152 is a large, high computational model, and the ResNet 18 is a small, high throughput model. It means ResNet 152 needs more GPU power to calculate the result. So it depends on the GPU in most cases. We also do the experiment by ourselves and with our own data. We use our own data of X-ray image, which is 768 by 768 pixels. As you can see, the highest performance occurs at 4 GPU. And if we proceed to the 8 GPU, the performance drops. And in this case, we use ResNet 18. We found it very interesting thing. The highest performance occurs at the 2 GPU, and the 4 and 8 GPU, the performance is even worse. How can this happen? Why do I spend so much money to buy 8 GPU, but I get even worse result? That sounds ridiculous.
Yeah, and also I don't have a lot of money.
Yeah. And we deep dive into every step of the AI training. The first step is data loader to retrieve the data from the hard disk, and the CPU do the data augmentation. And the second step, we move the data from system into GPU. The last step, the GPU do its computation. The first step is bottleneck occurs at GPU and I/O. Oh, disappear. And the second step, the bottleneck occurs at PCIe and NVLink bandwidth. And in the GPU computational power limits its speed. So we will discuss every aspect in the later slides. First, I want to mention what we have learned from these experiments. We found we should use your own data to do the benchmarking. Instead of most of the paper use ImageNet, this standard data set, to do their benchmarking. But you should use your own data because, for example, our own medical image is 768 by 768. It is 11.8 times larger in size than the ImageNet. So there is so much difference between the ImageNet data and our own image data. So the performance and the bottleneck will obviously different. And in practical, we use cyclic training with variable batch size. This means the GPU in most times the GPU don't hit the top utilization. It is not 100% utilized. So in the real world, the situation is very different than with the experiment and benchmarking environment. So if you want to choose your own hardware, I recommend all of you to use your own data instead of the standard image. And one thing, I think that this is very important, is to use half precision training. Half precision, also called FP16. It means 16-bit flow point. Because the normal precision is flow point 32-bit, and 16-bit we call it half precision. The advantage of using the half precision is to double the speed and half the memory consumption. It means you can save a lot of time and money. You can use less expensive hardware to achieve the same performance as others. Now we are talking about the CPU factor. We found CPU with 16 cores is quite enough. Using more cores usually doesn't improve the speed, and instead maybe even slower. According to our data set, we usually use 4 to 6 core CPU. It will provide us the most efficient and the highest performance. And we increase the core of CPU, the performance drop, just like the GPU example. The more GPU or the more CPU is not always good. But the higher speed in each core of CPU is better. It's better to find a CPU which its clock is high. It has high frequency and is high computational capacity of each core, of each single core. And we are talking about bandwidth factor. In most platforms, we use PCIe PCIe slot to insert our GPU into the PCIe slot. And the PCIe bandwidth is crucial. For example, if we adjust the PCIe bandwidth from 16 gigabyte per second to 4 gigabyte per second, the performance will drop about 40 or 50%. So PCIe bandwidth is really a large impact. In addition, some GPU has P2P communication. P2P means peer-to-peer. The meaning of the peer-to-peer is it allows different GPU to communicate with each other, and it will save the I/O bandwidth and gain some efficiency from the saving of the I/O bandwidth. Unfortunately, most of the gaming card, even as the highest end gaming card, NVIDIA 2080 Ti doesn't support the P2P communication. Only the higher end GPU for scientific computation, it will have the P2P communication. Next, we will see the GPU factor. We have listed many kind of the GPU which we can buy in the market. The V100 is the highest level GPU we can buy in the market, and most of the data center use V100 as their facilities. And the second is RTX 6000. RTX 6000 is also a very high level GPU card. But the difference is RTX 6000, its price is half the V100. So it's very, very cost effective. And the Titan V, is a mid-class. And the RTX 2080 Ti is the top-level gaming card. And the last GTX 1080 Ti, it can be used as the baseline of the benchmark, although it is end of life in the market. There are many specs we should look. For example, memory. For example, the V100 has 32 gigabyte HBM2, and RTX has 24 gigabyte. Titan V has 20 gigabyte. RTX has 11 gigabyte. Sometimes the memory will limit what kind of model you can use and how big the image you can input. So it is a very important factor when you choose the graphic card. And next spec we looked is Tensor Core. Tensor Core is built for deep learning. So the more the Tensor Core, the faster the deep learning model will be trained. The third spec is T-flops. It means tera flow point operations, and this means technically it means the speed of the calculation of this card. But in real world we should look at the real benchmark instead of the spec. This data is what I retrieved from some website data. Some experts have do those experiments. They use the GTX 1080 Ti as the baseline, is 1, and RTX 2080 Ti is 1.37, and the V100 is 1.72. And this is the price, and we can calculate the we use the benchmark divided by price. You may see the most cost effect, of course, the RTX 2080 Ti, and the V100 is least cost effective. But if you have a lot of money, you may buy.
I don't have money.
V100.
Donate.
But if you are doing personal project, you may want to buy RTX 2080 Ti. And if you are running a startup company, you may want to use RTX 6000 because it's quick, it's fast, but it's half the price of the V100. Last, I list some server prices here. We have surveyed from some vendors. This is for your reference. For example, the 16 V100 GPU server, it cost about $400,000 US. It's a lot of money. And you can see the AV100, 4V100, and 8 RTX 6000, 4 RTX 6000. It's for your reference.
FYR. FYR. FYR.
Okay.
Okay. Learning resources.
The last part is optional. I know some of you are already expert, and I shared the path of my learning in the AI. This is a typical AI model. This is their layer and structure. It looks very concise and it's not difficult. If you want to write an AI code, it's not difficult because there are some convenient framework to handle the complicated things in the background. You just have to write a few lines, a dozen of lines to make an AI model. Even if you don't know the algorithm and the mathematics, you can follow the online tutorial, like the PyTorch website tutorial, to write your own AI model. That's not very difficult for the programmer. Even if you don't know the theory, you can use the AI model. There are many choice framework you can use. They are all free, open source. For example, Keras, PyTorch, or TensorFlow. In the recent year, PyTorch, the usage of PyTorch is getting more and more, especially in the research field and the academic field. I personally use PyTorch in major because I feel PyTorch is more intuitive and the code is more comprehensible. And some online course is handful and very helpful. For example, Andrew Yang, I think many people have heard about him.
Hi, Andrew.
Yeah, he's a great teacher. His course is fantastic, it's excellent.
Okay, fantastic, Andrew, huh?
Yeah. And the last, I would recommend you a book. I think this is a very great book to tell us the background knowledge, the mathematics and theory of the deep learning. And this book also helped me to transfer this algorithm into the real code. I learned most of the deep learning theory from this book and Andrew Yang's website. Yeah, okay. I think I have finished my presentation.
I thought you want to share with us the view and
the view?
No, I mean the view, the ocean.
Yeah. Yeah, this is the ending.
Okay. So we have like 5 minutes for audio real-time Q&A, and I think there is a student raised hand. Yeah? No? Okay. What is the CPU spec should optimal for RTX 2080 Ti?
CPU spec. We have done several experiments for the 2080 Ti. We have been using the i9 9900. I think of course, it is the most powerful gaming CPU nowadays. One of the most powerful gaming CPU. I think if you have enough money, I suggest you to get the fastest CPU you can buy. But one thing I have to remind is that the server class CPU somehow it is slower than the gaming CPU. For example, the Xeon series. We have tried the Xeon series. The Xeon series CPU has many cores. For example, 24 or 32 core. The more core doesn't mean it will go fast, because the Xeon series CPU has lower clock speed, means its frequency is lower. Mm-hmm. For example, 2 gigahertz or 3 gigahertz. But the i9 9900 series may achieve 4 or 5 gigahertz speed. So I suggest you use if you have money, I suggest you use i9 9900. And if you don't want to buy some cost-effective choices, you may buy i9 7900. I think it's okay.
7900 US dollar.
Oh no, 7900 is its spec name.
Oh, sorry.
Yeah.
Yeah. Okay, so I found out there's a question. It's related with the resolution. Do you remember the? Oh, there's someone raised hand would like to interact with you.
Okay.
Dash.
Hello.
Yeah. Hello.
Sawadika. Hi.
Yeah. So I have a question, because when we're looking at the test on the GPU and the CPUs, it doesn't always means that having more cores makes it more efficient. Does that mean that the AI or the algorithm that we're using are not utilizing the multi-core to the maximum possibility, and hence that's why a single core with a higher clock speeds makes much more sense?
Do you mean CPU or GPU?
I think it's both, right? Because you're trying to, as you mentioned, you're using i9 9900 with the highest clock speed. That's not to bottleneck the data going.
Okay.
So you also, because I think it's on both, right? But we are using AI more on the GPU side, and still with more cores on the GPU doesn't really help. I'm just trying to understand: is it because the algorithm is not utilizing all the cores efficiently?
Yes. In our experiment, we have changed the CPU core utilization. We found the key factor is CPU load. We have to find the CPU load. CPU load we can see in the chart, statistical chart of the computer, of the operating system. For example, in Linux, it's called TOP, T-O-P. We have to look at the CPU load. If the CPU load is about 4, then we use 4 core of CPU to get the top performance. Because CPU load means the full usage of the CPU. The full usage of the CPU is 4 core of the CPU. And if we use more CPU, it makes no sense because there is no so many work for CPU to do. Why we provide more core for them to do? If we provide more core, it will waste a lot of time to split their data and into each core and collect each small data from each core. It will waste a lot of time. This is why the more core of CPU doesn't mean the higher performance.
Okay,
Okay.
so far so good.
All right. Yep.
Thank you. And is there anyone? No? Okay. So I think we have some questions.
Question? Okay.
Yeah. Okay. Right here. Do you have any implementation to combine laboratory results and radiology images to diagnosis?
We have think about it, but we haven't tried it because there is some limitations. For example, the lab data sometimes it is not very regular. For example, it may have the blood sample one day and make another blood sample another day, but the duration is variable. So how to determine which data we may use? It will make some confusion, make us confused. So we haven't tried, what do you say, to combine the laboratory test with the radiology images so far.
Okay. This one we have already answered. The question from Wu, it's the further question that we have answered, the resolution, the image resolution.
Okay.
Okay, and Wu wants to know, so the number of the images is more important than the size of the images?
Oh, you mean the size of images, the dimension of the image, and the number of image is the number of image in the data set. Am I right?
Can you rephrase your questions in our chatting room, and we will reply you later, and we will move on to the next question first, okay?
Okay. Oh, 这个可以啊。
Okay, so lots of transfer learning can help training the model. Do you suggest any one of the transfer learning models such as VGG16, VGG19, inspection V3?
Inception. Oh, it is misspelled. Inception V3.
Okay,
Yeah.
others.
Yeah. Of course, it's always good to use transfer learning. It will not only save a lot of time of training, but also provide provide higher accuracy. It will achieve in the less training. There are many classical models on the website, and they also provide their pre-trained model for even as the latest models. So I think it is necessary to use transfer learning to train the model. It's very useful.
Mm-hmm.
Yeah.
Okay, so one more, the last question.
Okay.
Mm-hmm.
Why you students?
Okay, so we will put the priority on frequently asked questions. As for the rest of the questions, we will update on the QA section of CoreLab. Okay, so
我来回答那个 size.
Okay, the number of the image is more important than the size of the images.
I guess what you are asking is the number of the image of the data set is more important than the dimension, the size of the single images. Because based on our previous experiment, the size of the image, it does affect the result. For example, if we downsize the image to a very small size, for example, 256 pixels, the final accuracy will drop a lot. So it is not good to shrink the image into too small size. But I think we should use the reasonable size of the image, because to some extent, if you use the very large image, it doesn't provide more accuracy. It usually has the same accuracy as some certain dimension of image. For example, the previous question is 2048 by 2048. I think this is for the X-ray image. This will be too large, because the 1024 is already the same with the 768 pixel image. So the larger image is wasting time and wasting the money of GPU.
Okay.
But the number of image is very important. I think the more the image you have, the better. It will improve your model's robustness and its accuracy.
Okay, thank you, Kevin. And this is the last question. If you have any further question, please leave the message on Zoom, and we will reply you as soon as possible. And thank you all very much. Do you want to say something?
Say something?
No. Actually, I think next class is my last class. I will be graduate from TTAIC. So really nice to meet you here. Yeah.
Lucky to meet you.
Same here. And our next class will be on this Thursday, and the Zoom ID and the link is already shows on the CoreLab. And if you missed the class, please don't worry. We have the class recording, and we will update on CoreLab as well. And we're still calling for the presentation on April 30th. We encourage you and your team to participate. And please sign up as soon as possible before April 17th. And we only have 10 spots. The sign-up link and the detailed information are announced on CoreLab as well. We look forward to seeing you online. Thank you again, and enjoy the tonight. Thank you. Goodbye.
Goodbye.